Now in class 11th, I will tell you about the rolling friction. Rolling friction. When a body rolls over the surface, the friction due to rolling motion is called rolling friction. A body is said to be rolling if its point of contact with surface changes continuously and its center of gravity moves in forward direction. तो क्या है, जब कोई बॉडी रोल करती है तो उसका पॉइंट ऑफ कांटेक्ट होता है सरफेस के साथ, तो वो हमेशा चेंज होता रहता है. जस्ट वी हैव सीन द व्हील्स मूविंग ऑन द फ्लोर और मूविंग ऑन द रोड, then the point of contact of the wheel with the earth or the ground always changes, but the center of gravity moves always in the forward direction. So the rolling, there is the motion of the center of gravity in the forward direction. So now this rolling friction may be due to two reasons. It has two reasons. Now first is the body creates depression in surface with its contact, and and elevation in forward direction, in front of it. तो ये किस तरीके से, let's suppose we are having this surface, this is not surface, this is surface, this is the plane surface having no elevation and depressions at all. But when there is this is the plane surface, then what happens? Suppose here we are having some body on it. This creates what has happened? This is now surface. So this is the depression and this is elevation. This is now elevation. Elevation. And this body has created a depression here. This is now a depression. Depression. तो बॉडी जब रोल करती है तो इस तरह से वो क्रिएट कर सकती है, इसमें डिप्रेशन क्रिएट कर सकती है. जब डिप्रेशन होता है तो इसका आगे का जो पार्ट होता है वो इसमें उठा हुआ प्रतीत होता है, एलिवेशन प्रतीत होता है. दिस इज नाउ एलिवेटेड पार्ट. So this helps that the body is climbing up the elevation. It appears that body is climbing. Climbing the elevated part. Giving rolling friction. And second reason is what? Now it may so happen that the body in contact with the surface get flattened, so the area of contact increases. The get flattened, which increases the area of contact with surface. तो ये बॉडी है. Now suppose this may be so like this one. Now this area has been flattened so much. This is the body, this is the flattened area. This is now flattened. So what that whenever we have to roll to this one, this is not rolling like this one. This is also rolling like this one. But its center of gravity always goes in the forward direction. So center of this is rolling in this way. This suppose this now we are having the surface. Suppose I take to this one. This is now surface. This is now suppose the body, and that this rolls like this one in this way. So now what we have, that the center of gravity goes in the forward direction, but the point of contact with the surface changes. So when this creates a depression in the surface, then it appears that the body is climbing the elevation that is created by it in front of it. So because of that there is a friction. But there may be this also, that this body may have the flattened. When this body is flattened, then the area of contact with the surface increases. So this also gives rise to the rolling friction. The flattening of body gives the rolling friction. So thus there are two regions. One is the elevation or depression created by the body, and second is the part of the body that is in contact with the surface get flattened. Thus, these two regions may have the combined effects causing rolling friction. Rolling friction. The rolling friction is very small in comparison to the static friction and the kinetic friction. The rolling friction is very less than kinetic and static friction. This rolling friction does not depend upon the area of contact. So rolling this rolling friction is less than the kinetic friction or the sliding friction. Kinetic or sliding friction, and this is less than static friction. It means what? That this F R less than F K less than Fs. So this Fr now we know that Fs equal to mu s into R, and this Fk is mu k into R. And this Fr is mu r into R, where mu s the static coefficient of friction, mu k kinetic coefficient of friction, mu r rolling coefficient of friction, and R the normal reaction. So we can have this mu s, mu r less than mu k less than mu s. This is what we are having with this one. So the rolling friction is very small because the area of contact is very small, the body and that of the surface. So this is about the rolling friction. So thank you very much.